Hello, welcome to this tutorial video. In this video, you will learn how to program and code simple player movement in Unity. And here I have a first-person shooter game that me and my group have designed, and I will go over the movement with y'all today. Okay, so to start off, we want to set up our player. So first, we'll just create an empty object, and you can do that just like right-click and create empty object, and you're going to name it player. Simple as that. And in the hierarchy, you'll just drag the main camera into your player and make it a child. Alright. So in this game, we use the character controller rather than the rigid body because for just simple movement around and not wanting to crash into walls like you in an FPS game, it's easier to work with a character controller. So in the character controller, you want to add a character controller, go to add component and search up character controller. And here I already have it added. And our character controller, we're going to create it. As you can see, it's this green outline here. We have a radius of 0.3 and a height of 2. And you can scale it to whatever game you want. But in this game, we're using the height and radius. These are the two important things for determining the size of your player. And then inside the player object is where we're going to create a new 3D object, and that's going to be a cylinder. So once again, just right click, you can go to 3D object, and you just choose cylinder. And since it's a character, it's a child of the player, it'll already be in here. So let's just click on it here, and you want to make it so that it fits the character controller. And all you have to do for it to fit our character controller is just change the scale and put it at 0.5 in the X and 0.5 in the Z, and don't change anything else. And also another child you want to add is ground checker or ground check, and we have it here. At the bottom, just move it to the bottom of the player because you're going to be using that to check if it's at the ground. So in our player here, since the height is 2, we have it at the scale it is 1. We put the position -1 in my game, but here all you have to do is just scale it up or down to just match it to the bottom of the player. Alright, now we've actually set up our player, we can start getting to the code. And the first thing for player movement, you want to be able to look around. So first, we're going to start off with coding how to just simply look around using the mouse, and this will be done in our main camera. So all you do is just add a component and search up script, and you just click new script. And here we already have one here, right here, and just name it look, and we'll open up that code so we can look at it. Okay, in our code, we have these instance variables, which will be used as we go later on throughout the code. So the mouse sensitivity is just, as it explains, mouse sensitivity, we're going to set it to 100. This rotation is what we use for looking around, just rotating, especially in the Y direction. And then transform player body is just to reference the player. Alright, so in the update method is where we code the little movement for looking around and tracking the x-axis and the y-axis of the mouse. So here we'll just make a new float as a mouse here, and input the axis, inputting we get axis the mouse x, which is already defined in Unity. Just make sure you have that space. And for y, name it mouse y and make sure you have this space because this is how it's predefined in Unity. But you can go into the settings and you can change it if you really want to. And multiply by the mouse sensitivity. And we also are going to multiply by delta time so that this will allow for movement independent of the current frame rate. And so here, just 2 lines of code here will give you the input, and then here we get to the rotation. This line here is all you need for X rotation. But if we want to calculate, this is for, and there's 3 lines above are for the Y rotation, so for looking up. And here we just set our rotation to minus equal to mouse Y. If you change it to plus equals, it'll just flip the rotation, so just make it Y equals. And in here, math of clamp, this clamps the rotation. So when you look up, like in real life, if you look up, you can't move your neck all the way back and look behind you. And if you look down, you can't go through your body and look behind you. So mat.clamp will clamp the rotation, so you stop once you're looking up and you stop once you've looked down. So all you do is just set the rotation, mat clamp, X direction is, X axis is just rotation, and then negative 90 for the Y and 90 for the Z. And then just do the rotation, transform local rotation. There's quaternion. This actually handles rotations in Unity, and this is just a Euler angle, and this is the angle we're going to have it in, which is the rotation angle. And once you have this code in, it will rotate. And this also here will lock and hide the cursor. So when you're in the game, you don't want to have your cursor on the screen as you're playing. You want to have just the screen. So this will just hide the cursor so you don't see it when you start the game. And now let's go back to Unity so we can see how this actually looks. And I'm going to uncheck the level so you can actually see some things. And we're going to go to the main camera inspector, and we have to make sure you assign the player body just to the player, so to reference that. And when you play, you see you're able to look all the way up, look all the way down. You can't look behind you and look around all like that. And you notice the cursor is hidden, and it's here. Now we have our crosshair so we can use to aim at our enemies. And exit out, or just press escape to exit out, and we're back in. Alright, now that we have the looking part done, let's go back to, now we're going to go to the movement, which is just like walking and jumping is what we'll cover here. So, now we're just going to do walk movement, so let's go back to our player, and we're going to, once again, add a new script, and it's going to be called move. And this is just for us to be able to move around. Let's open this up. And once again, here we are in move. And here are the instance variables that we will be using further on in the code. The controller, so character controller just is going to be used to reference the character controller we have on the player. This transform ground check is going to reference the ground check child we have in our player that we'll be using to check the ground, check if we're on the ground so we can jump. We'll discuss that later. And these ground mask and ground distance is also going to be checked as well. And this layer mask, ground mask actually references a layer. And in our game, we have our ground is layered ground, but I'll show you how to give it that layer later on. And this is just a Boolean value that will be true if the player's on the ground, and false if not. And here's just velocity we'll be using for jump speed. This is speed here is just regular walking speed. And since we're using a character controller, it's not programmed with gravity, so you have to manually add it yourself. And then J height here is just how high we jump. So actually for movement, you don't need a start method. There's nothing that needs to be coded in the start method, so we can just skip that. And we'll head straight to the update method. First thing we're doing here is we're just going to get the keyboard input. And once again, Unity has it defined as horizontal and vertical. And horizontal references if we were using with WASD keys, horizontal represents the A keys and the D keys as well. If you're using the arrows, it represents the left arrow and the right arrow. And then for Z, which we're calling it Z, we're going in the Z direction because we're not going to go straight up in the air as it is in 3D. And this is the vertical, so we'll get the up and down arrows, and it'll also get WS keys. So here we'll start with the walking movement, and just vector 3, we'll add a vector 3 for movement, and transform right times X will move us to the right, and transform forward times Z will move us, to the right and left, and transform forward times Z will move us forward and backwards. and it also does this in relation to the direction we're facing. So if I'm facing one way, it'll move that way. It's not like your vision's just stuck and you'll just keep moving in the same box. It'll make you move in relation to the direction you're facing. And then controller.move is just to actually move our player. Just move times the speed, so that's how fast it's going to move. And once again, multiply by times delta time, so we're independent of the frame rate. And then probably the most difficult thing, or not difficult, but the one that'll take most thought is jumping. So jumping, you have to make sure it's on the ground, because if you don't check, that's what this is grounded check is for. Let's zoom out a little bit so you can see the code. It'll check if the player is on the ground. Because in Unity, if you don't check that, you can continuously just tap the space bar, and it'll just keep jumping up in the air. So we want to make sure it's grounded so we don't allow for double jumps, triple jumps, infinite amount of jumps. And to do this, this is physics check sphere. What we're doing here is it references that ground object, which I'm going to go back to real quick just to show you. The ground check object here. It'll create a little sphere around it. We'll create a little sphere around it, and it'll get the position, which we have it at the bottom of our player, so it represents like the feet. The ground distance, that's just like the radius of the sphere to check if it's touching the ground. And the ground mask, it's the layer it's checking if it's colliding with. And actually, now that we're at this point, ground mask here references in the level the floor we have here. As you see, this layer is ground. So whenever you have if in your game, make sure the floor has a layer separating it so you can check that. And if you don't have a layer, all you have to do is just click on it, add the layer, and then you can go back in and add it. Simple. All right, back to the code. So it is grounded. You have to use this is the Boolean value to see if it's on the ground. It will be true. If it's not, it'll be false. And here's just the if statement we have, so we can jump whenever spacebar is pressed and we're on the ground. So input.get button down jump. In Unity, jump is predefined as spacebar. You can also do input.get key down and just put space, and that'll also give you spacebar. And we want to check if it's on the ground. So if this is true and both of these variables are true, then we're going to change our jump speed in the y direction, velocity y direction will be this equation here, and math square root jump height. So the equation for jumping is actually square root of h times 2g, where g would be the gravitational constant. And then, so here, once we have, if we press spacebar, it'll jump. We still have to program in gravity so it comes back to the ground. So here, velocity y is adding gravity times the time.delta time, once again, independent of the frame rate. And notice we're having plus equals, but remember when we have gravity goes down, so it's a negative value. And make sure once you get into the Unity editor and you go back to the player, you want to make sure that your gravity is negative. Earlier, notice my player wasn't going down, he was going up, and sometimes that can be that it didn't have your negative here. And then once you have that, just controller.move, and it'll just move it down. So it'll constantly be moving down or having gravity effect on it, on your player. So this code here will give you your movement, and there's this little comments here that I'll show. And then once you have that, all you have to do is go back to the game, play it, and with everything together, you can now look around where it's spacebar to jump, and there you have it. And you can move around and just do all that, and then enemies can ignore that. So here's like a little barrier, you could jump over that, and boom.